Hello, welcome back to Sri Sai Tech Edu YouTube channel, Read Lead Success. We are already started with the network analysis and control systems module 1. In that, we have studied many of the concepts of basic circuit elements. We will see some more few concepts in this. I think this is the last topic of the basic circuit elements, module 1 first chapter. In that, we have mesh and node analysis. We have already completed introduction, circuit components, definition, sources of electrical energy, source transformation, general network transformation, and we are left with mesh and node analysis. Still more two videos, that is mesh analysis, one video. I'll do separately mesh analysis and node analysis. Today we'll go with mesh analysis. Mesh analysis. We've already seen what are meshes initially in the introduction, how meshes look. This is one mesh, this is one mesh, and this is one mesh. Mesh 1, mesh 2, and mesh 3. Three meshes. How many loops? 3 loops. 1, 2, 3, and you can also consider this kind of loop, fourth loop. For loop, in loop they can be inside there can be any other loops also, and in loop there can be different meshes also. But if you consider a mesh, inside a mesh there should not be any other components or any other meshes or loops inside a mesh. So the mesh should be single. Here if you see, we can write the mesh analysis using KVL. We have already seen what is KVL. KVL is nothing but the sum of all the voltage drops at all the components, algebraic sum of all the voltages will be equals to 0. So how to write? If you apply KVL to this mesh 1, what happens? See, when you are taking, it is a clockwise direction, no? If you are taking this clockwise direction, take this also clockwise direction, take this also clockwise direction. Then consider this as plus and this as minus, this as plus and this as minus. Consider in this way only, plus minus and plus minus. While applying KVL, initially an end sign is what? Plus. So plus EX, end sign is minus. So minus Z1 I1, minus Z1 I1. Why? We want voltages across the components. Voltage across this component Z1 is what? R into I. V is equals to IR. No, here impedance they have given. So I1 into Z1 minus I1 minus then Z3. Z3, if you see, Z3 is between two meshes. Right? Z3 is between two meshes. Z3 is between two meshes. So what we should need to do? Here if you see, the current is flowing here in this way. As the current approaches here, it moves in this way. In this, what is happening? In this, the current I1 is moving in this way and I2 is moving in this way. Because of that, there is an opposite current. So what we need to do? Z3 into the mesh what we are considering. That mesh's current minus the second mesh in which the current is moving through that resistor or the impedance, that is I1 minus I2. You need to consider in this way, that equals to 0. If you take EX this side, EX will be equals to I1 Z1 plus I1 Z3 minus I2 Z2, I2 Z3. I1 Z1 same, I1 Z1 only you will get. Here I1 Z3 minus I2 Z3. Z3 is common, so Z3 you take common and I1 minus I2. Same, no, same what you got that only. I1 minus I2. Then you don't have Z2 component, so 0 Z2. In this way we are going to write. Okay. For first mesh. Other meshes also we follow the same thing. This is for the first mesh what we have written. For the other meshes also, mesh 2 and mesh 3 also, we will follow the same thing. We'll see how the equations look here. See, mesh 1. See how I have written that only it is. I see I1 Z1 plus I1 minus I2 Z3 minus equals to 0. Z1 plus Z3 is equals to Z1 plus Z3, I1 is common. So Z1 plus Z3 I1 minus Z3 I2 plus 0 I3. There is no I3 component. So 0 I3, that is equals to Ex. In the same way mesh 2. We'll analyze mesh 2. When analyzing mesh 2, what we need to do? Put here plus, minus, plus, minus, plus, minus, plus, minus. If you see I2 minus I1. While considering the mesh 2, we need to consider first the mesh 2 current for Z3. So Z3 into I2 minus I1 we need to write. Here we have written Z3 into I1 minus I2. Why? Because we are considering mesh 1. So first mesh 1 current we need to mention, then subtract I2. But here we are considering mesh 2. So as we are considering mesh 2, we need to consider first mesh 2 current. So I2 minus I1. Then I2 Z2 plus I2 Z2 plus I2 minus I3. Again see, mesh 2 current first. Why? Because for Z4 we are considering mesh 2. So I2 minus I3. Current is moving here in this way, here in opposite way. So I2 minus I3 plus I2 Z5. Done. After again we rearrange it, what we get? Well, rearranging what we get here, we need to divide, we need to make I1 components one side, I2 components one side and I3 components equals to 0. Then for mesh 3, for the mesh 3 also same way we need to consider. After considering this 3 equation, mesh 1, mesh 2, mesh 3, what we need to do? If you see, this is 1, this is 1, this is 1. We can write a matrix form, no? How? Z1 plus Z3. Matrix form we can write Z1 plus Z3. Then minus Z3. 0. And here minus Z3. I1 component. Then Z2. This Z2 plus Z3 plus Z4 will write here. And minus Z4. And in this form we will write a matrix. I'll show you that in the next slide. To just know, there are no equations in the next slide. So only I'm showing here how the matrix is written. And here again 0 Z1 minus Z4. Using these 3 equations, we will write what? Matrix. How we will write, we'll see in the next slide. See here. I've said no, this I1 component Z1 minus Z3 is 0. I2 component I1 in the I1 component minus Z3, I2 component is Z2 plus Z3 plus Z4, Z4 plus Z5, and I3 is minus Z4 I3. 0 I1 minus Z4 I2, Z4 plus. If you compare these equations, those equations before equations with this, you'll understand how this has come. We should write the matrix form of that. That's it. We need to multiply it with what? I into Z, that is equals to E. E is equals to IR. E or V is same. E or V is same. E is also potential. V is also potential. E equals to IR. We even mention with E also. Or E. E or V is same potential. So that will be equals to I. I into R. Here R is what impedance they have given. Impedance or resistance is same. So I into Z in same way. This we have written in the matrix form, and I1 also in matrix form, column matrix. I1, I2, I3. Ex is 0. We got Ex right hand as E is 0, this 0 and minus E1. After writing this all, what we can do? We need to find what? We need to find the mesh currents. They ask in questions also, find the mesh currents. I1, I2, I3. How we can do? One way is Cramer rule. We can use those 3 equations, and using calculator also you can do. But even doing it through Cramer's rule also we can find. How we can find using Cramer's rule? We'll see. I1 is equals to 1 by delta. Delta is what? Delta is for the matrix of this, delta of this matrix. Nothing but det. debt we need to take. Debt how we will take? We'll consider this into this in this multiplication minus this, we do know. That way we need to consider the delta value here. In sum I will show you in one sum I will show you how to do. Anyway, in the next sum you just see the formula here, 1 by delta ex0 ey. What we need to do is, if you want to calculate I1, the first column, as we are calculating for I1, the first column need to be replaced by this one, that is ex0 e minus ey. Now other two columns are same, see here, other two columns are same. Then for I2, what we need to do, the second column need to be replaced by this. Then the first and third column will be same. For I3, the third column need to be replaced by this. Then first and second column will be same. After doing this all, for delta, here it is there, see how to find delta. How to find delta? How to find delta? Delta is equals to z1 plus z3 minus z3. This is the delta. If you take delta of this, you will get the delta value. Substituting here and finding this debt value, debt of this value, this by this you will get the I1 value. Okay, this is a formula. I'll show you how to do practically in the sums, so we'll get clear picture how to do. This is the generalized mesh equation, that is Zi is equals to E, which I've told you before itself. Zi is Z matrix, I is equals to E. This is the generalized equation. We'll see a question so that you'll understand how to do. Find the power dissipated in the resistor R in the ladder network shown in figure. Choosing the loop currents I1, I2, I3. See, clockwise direction, take all clockwise direction. If they don't mention any direction in the question, take a clockwise only. If they mention the direction, you should consider that direction only. But if they are not mentioning, take clockwise direction only, so that it will be easy for calculation. Take it. Then what we need to do? We need to write KVL equations I1, I2, I3 for to calculate. What is the KVL for? Apply KVL for what? First mesh. We will write 1 here, plus minus plus minus. If you consider 1 minus 1 I1 minus 1 I1. Why? R into I. Nothing but voltage drop across resistor. So 1 into I1 minus 1 into I1 minus I2. Why? Because they are considering first mesh. So we need to minus I1 current minus I2. Why? Because both currents are moving through resistor. We need to consider both currents. I1 minus I2 equals to 0. If you rearrange, you will get 1 equals to 2I1 minus I2. And then we'll see the KVL for second mesh. In the same way, what we'll do? First we'll write, again we need to consider the currents, no? Plus, minus, plus, minus, plus, minus. Consider in this way now. After considering, what we need to do? 1 into I2 minus I1. Okay. Then just 1 I2. Then 1 into I2 minus I3. If you rearrange this, you will get minus I1 plus 3I2 minus I3. Okay. Then what we need to do? The third equation we need to find. What is the third equation? For third equation, we will consider the third mesh. 1 into I3 minus I2 plus I3 plus I3 and plus I3. Why? Because both have only one current, I plus 1 I3 plus 1 I3. 1 into I3 minus I2 equals to 0. If you rearrange, you will get minus I2 plus 3I3 equals to 0. Okay. After doing this all, we need to find I1, I2, I3. We need equations. So it is in the form of I1, I2. If I3 is not there, you need to consider 0 I3. Remember this, 0 I3 need to consider. Okay. Here all the three components are there. Here I1 is not there, so consider 0 I1. Okay. After considering, If you solve these three equations, then what you will get? I2 as 3 by 13. Then power, if they want power in the resistance R in the ladder network. Resistance R in the ladder network. They want the power in the resistor. If they want the power in the resistor, what we need to do? We already know the I2. I2 is what? I2 square. Power will be equals to I square R. If you remember the formula, I square R. I square is 3 by 13 whole square. That is nothing but 9 by 169. R is anyway, it is 1. So 9 by 169 is the power. Power in the resistor in the ladder network. So in this way we will find the mesh currents and how to do mesh analysis. I hope you understood. Why? Because while mesh current we take KVL. KVL will put for all the meshes. You should know KVL very well while doing this. Then alternate method. We have seen in the before slides the Cramer's rule. No, I'll show how to do using Cramer's rule now. These are the 2-3 equations we got already. I've put once again here. These equations, what can we do? We can write in matrix form. See here. I1 component is 2. I2 is -1. I3 we don't have, so 0. I1 is -1. I2 is 3. I3 is -1. For my 0, I1 there is no 0. I2 is -1 and I3 is 3. Okay. Then what we need to do? We need to multiply the matrix I1, I2, I3. Why? Because it is V into, that is Z into, or R into I equals to, sorry, and this is R into I equals to V. So it is in this form. So we need to write in that way. After writing, here if you see the right hand side is equals to 1, 0, 0. 1, 1, 1, 0, 0. Okay. After writing this, we need to take the Cramer's rule. We want mesh current I2 to find. Okay. To find mesh current I2. Why? Because they are asking power dissipated in R equals to 1. The same Cramer's rule can be used to find I1, I2, I3, but I am showing only for one current, that is I2. How to do? How to do I2? I2 is equals to delta 2 by delta. Delta 2 means what? Delta, first we'll find delta. Delta is what? 2 into 3 3s are 9. 9 minus 1 1s are minus 1 into minus 1 is plus 1. So 9 minus 1. You will get this. Then you should consider minus 1 we got. That is, we need to take this. If you remove, then you will get minus 3. Now we need to consider what? I think you all know matrix how to find. If this is not there, then what is it? 3 minus 3 minus 0. So you will get minus 3 minus 0 plus, as it is 0 0 into 0 into what we will take. Now we will consider, you don't consider this column, then my 1 minus 3 into 0 is 0. 1 minus 0. If you find in this way, you will get the matrix. How delta is equals to 13 you will get. After getting delta is equals to 13, we need to find delta 2. Delta 2 is what? Delta 2 is nothing but you want I2. I2 means what we need to do? We need to replace this second column with 1 0 0. This right column. How we will now we will see how it looks. 2 minus 1 0. This second column. The second column is replaced by 1 0 0 and third column is same 0 minus 1 3. 0 minus 1 3. After doing this, what we need to do? 2 into we need to find delta of this again. 2 into 0 minus 0, then minus 1 into, we need to take minus for the second column. I think you know the rules of the matrix. So minus 1 into minus 1 minus 3 minus 0 minus 3 minus 0 plus 0. 0 into 0 minus 0 anyway. Delta 2 you will get 3. I2 is equals to 3 by 13. I think if you see the previous slide, previously what we got is 3 by 13 itself. For finding resistance, what we will do? The power in resistor is I square I2 square into R. I2 square is what? 3 by 13. 3 by 13 is nothing but 9 by 169. R is anywhere here it is. R is anywhere here it is 1 ohms. So 9 by 169 is the power. So we'll go to the next sum. Determine the power supplied by the 2 volt source. This 2 volt source, how much power supplying we need to find. We'll see how. Initially, consider the circuit in the same way and consider this as mesh 1, mesh 2, as it is we are doing mesh analysis. Using mesh analysis we are doing, and consider the currents I1 and I2 in the clockwise direction so that it will be easy for you. Then after considering, what you will do, write the mesh equations, that is apply KVL to mesh 1. How to apply? Already I have mentioned plus minus is in the question itself. While doing itself, 5 volt minus 4 I1, 4 into I1 minus 2 into I1 minus I2 plus 2 equals to 0. By rearranging you will get the first equation. Then apply KVL to mesh 2. Mesh 2, how we will apply? Minus 2, that is from the here considering in this way, clockwise direction. So minus 2 into I2 minus I1. Why? Because we are considering the mesh 2. So first mesh 2 currents need to be taken, then first mesh 1 current. So I2 minus I1. Here we are considering mesh 1. So first I1 minus I2. Here I2 minus I1. Why? Because mesh 2 we are considering. Then 5 into I2. Okay. Then minus 1. Plus minus 1 it is there. So end sign is minus. So minus 1, that equals to 0. After writing these two equations, what will we do? After writing the two equations, we need to find the current in the both meshes I1 and I2, so that we can find the power supplied. Solving 1 and 2, we can do one of the method is what we can do in this way. How? That is 6I1 minus 2I2 equals to 7, minus 2I1 plus 7I2 equals to minus 3. If you for cancellation method, if you multiply this with 2 and this with 6, this will become 12I1 minus 4I2 equals to 14, minus 12I2 plus 72I2 minus 18 it will become. So this can be cancelled. Why? Because plus minus can be cancelled. Then if you calculate this, 38 I2 you will get, then minus 4 I2 equals to, so you will get I2 you will get as this. To get I1, substitute in any of the above equation, you will get I1 equals to 1.132A. These are the two ways you can do the what I1 and I. This is a one way. Sorry, another way I will show you now. This is one way you can find I1 and I2. One more easy way is using calci. Before that, we will see the power at 2 volt supply, how we will do. Power equals to what? V into I. V into I. Power at what they are asking? 2 volts. 2 volts is in between of this and this. Power supply by 2 volt source. So 2 volt source means voltage into I. Power is V into I. V is what? 2 you know. 2 volts. And you want the current. The current passing through this is I1 minus I2. No, I1 minus I2. After doing I1 minus I2, what you will get? 2.474 watt. Okay. See, why I1 minus I2 is, here the current is moving in this way. Here this current is moving in opposite way. So I1 minus I2. You got the power supply. Now we'll see the next method, how we can find I1 and I2. This is the cancellation method. Using calci, how we will do. We will see now that.
Here you can see there are two equations. For doing one of the method is to solve the equations is this. But if you want directly from these equations values, we can use calculator to do that. Initially what you will do, go to mode, press 3 times. 1, 2, 3. Then you will get an equation kind. Click 1. Then unknowns are how many? 2 are the unknowns. So click 2. So you'll get A1. A1 you should give as 6. Then you should press equals to. Then you'll get B1. What is B1? Minus 2. Minus also you should give here. Minus 2. Equals you'll get C1. That is equals to C1. This is C1. You need to give as 7. Again equals A2. Second equation. Minus 2. B2. 7. Then C2. What is C2? Minus 3. Equals to if you press, you'll get I1 as 1.1315. See, I1 as 1.1315. Nothing but 1.132. Then I2 as, here you'll get as X and Y. But while taking only, you need to understand that what is X and what is Y. If X is I1, then Y will be I2. So I2 will be minus 0.1052. Minus 0.1053. So using calculator also easily we can calculate. Here while taking, initially if you are taking this as I1, here also I1 value only you should take. This is A1, A2 and A1, B1 and C1, A2, B2 and C2. If you are taking in this way, the value what you are getting, I1 will be X and I2 will be Y.
Now let us see next problem. Use mesh analysis to determine the 3 mesh currents in the circuit. We need to find the 3 mesh currents, that is I1, I2 and I3. How to do? Same, apply KVL to mesh 1, write the mesh equations, that is 7 minus 1 into I1 minus I2. Why I1 minus I2? The first mesh current is I1, the second mesh current is I2. So I1 minus I2. Then minus 6 in minus 6. Why? Because the end sign is minus 6 and minus 2 into I1 minus I3. Why? Because first mesh current is I1, next mesh current which is flowing through this resistor is I3. Rearranging, you will get this equation. The same way we apply KVL to mesh 2, mesh 2. Then for mesh 3, after applying through mesh 3, we can use either Cramer's rule or you can use the calculator to find I1, I2 and I3. Then determine the current I1 in the circuit figure. We need to find the I1 in the circuit figure. Same, applying the KVL. First we will take this as I2 and this as I1. Why? Because I have already mentioned I1 in this question. So consider this as I1. Then this as I2. Write KVL to left mesh, that is 5. Then plus 4I1 plus minus 4I2 in I2 minus I1 minus 4I2. Rearranging, you will get this equation. Then apply KVL to this right mesh. After applying, you will get the equations in this way. Minus 4 into I1 minus I2 minus 2I1 minus 3. You will get this. After solving these two, you will get I2 and I1. We require the I1 current. You will see this question now. Determine the current I1 in the circuit. We need to determine the current I1. Same way we will write the directions I2 and I1. We will write this I2 and I1, the directions of the current clockwise. Then what we will do, we will write the KVL, using KVL we will write the KVL to the left mesh. What you will get, 5 plus 2Vx minus 4 into I2 minus I1 minus 4I2 equals to 0. Then rearranging, you will get this equation. Then if you see 5 equals to, after rearranging you get like this, 5 equals to minus 2Vx minus 4I1 plus 8I2. Where if you see Vx, the potential across this Vx 4 ohms, what it is? I2 minus I1. Okay, I2 minus I1. Okay, if you take I2 minus I1, then you need to substitute this Vx in this. Then you will get the value as 5 equals to 4 I1, I1 equals to 5 by 4. I1 is equals to 1.25 ampere. Here, if you see, no need to write the equation for the right mesh. Why? Because you already got I1 value. We want I1 value in this circuit. If they ask I2 value also, then you need to write the equation for second mesh also and find the I2 value. Okay. Then next question. Determine I1 in the circuit of the figure if the controlling quantity A is equals to, this A is 2I2 and B is 2Vx. Two different questions are there. First we will see 2I2. A is given as 2I2. See, I took here A is equals to 2I2. Right, apply KVL to both. Already the directions are given. Apply KVL to both. KVL to mesh 1, then you will get the equation as like this, that is 2 minus 2I1 minus 5 into I1 minus I2 plus 2I2. You need to start solving this so that you will understand how I am writing the KVL equations. So you need to start solving them. Then apply KVL to mesh 2, or you will get minus 5 into I2 minus I1 minus 3I2 plus 6 minus 4I2 equals to 0. After writing, you will get the second equation. Solving them to, you will get I1 value. We want I1 value. We found the I1 value. Okay. Here we need to find for 2Vx. We have already solved for 2I2. We'll put 2Vx in this A place and we'll find, consider A equals to 2Vx. Apply KVL to mesh 1. What you will get? 2 minus 2 plus minus 2I1 plus minus, that is 5 into I1 minus I2 plus 2Vx equals to 0, where Vx is equals to what? 5 into I1 minus I2. As the plus minus sign is given this side, you take this related only. Vx is equals to 5 into I1 minus I2. After substituting that, you will get the first equation. After that, you need to apply KVL to mesh 2. By applying KVL to mesh 2, what you will get? Minus 5 into I2 minus I1 minus 3I2. Here it is plus minus, no, so minus 3I2 plus 6 minus 4I2. After getting this, you will get a second, after solving this, you will get a second equation. Solving both 1 and 2, you will get I1 equals to 546 milliampere. Using calci you can find, or using Cramer's rule also you can find. You can use whichever is easy for you. Then calculate the current Ix in the current of the in the circuit of the figure. We need to find the Ix here. How to find? We will see now. First, initially put the currents, like directions of the currents, I1, I2. As they are given Ix, you consider as Ix itself. Consider Ix only, current flowing through this, and then apply KVL to mesh 1. How KVL is applied? 3 plus minus 8 ohms minus 8 I1 plus minus 4 I1 minus I2 equals to 0. By evaluating this, you will get this equation. As there is no Ix terms, put 0 plus 0 Ix. Then apply KVL to mesh 2. Applying KVL to mesh 2, what you will get? Minus 4 I2 minus I1 plus minus 12 I2. Then again plus minus 8 I2 minus Ix equals to 0. As Ix is passing through this, I2 minus Ix, 8 into I2 minus Ix. After evaluating, you will get the second equation. Then applying KVL to mesh 3, what you will get? Minus 8, again here plus minus 8 into Ix minus I2. Then here if you see carefully, if here is plus minus 20 into Ix minus another current which is flowing is opposite, that is 10 ampere is flowing. So Ix minus 10 you need to take. Then plus minus 5 Ix equals to 0. After this, if you equate it, I hope you understood this, minus 20 into, as the current 10 amperes is also flowing through this resistor in this way, opposite way. So Ix minus 10 you are taking. The same way how we consider for the meshes, no, in the same way as the other current is also passing through 20 ampere to 20 ohms. So you need to take 20 into Ix minus 10. Okay, after taking it, you will get the equation, third equation also. After getting the third equation using calci, as I've shown in the initial only one video how to find two unknowns for that. So in the same way you can calculate for three unknowns also. Solving 1, 2, 3, you will get the Ix value. Okay. Employing the mesh analysis procedure, obtain a value for the current labeled I. We need to find I in this in the circuit. How to find, we will see. We will see how to solve now. See, we will write in this way. As it is connected to this point, you can directly connect like this in this way, 3 ohms, then 2 volts. Consider the currents I1, I2 and I3. As if you see here, the current is giving in anti-clockwise. Consider in anti-clockwise itself for all the equations. Why? Because all the meshes. Why? Because as I have given in anti-clockwise, no, consider all the currents in anti-clockwise. Don't consider in clockwise. It will be confusion. Consider as they have given in anti-clockwise in one direction, consider others also in anti-clockwise. We will see how to write the equations when it is anti-clockwise. Apply KVL to mesh 1. How we will write? If you see here, this will be plus and this is minus. As we are starting from this side, plus and minus. If you see here, plus minus I1 minus I3 minus 4 into I1 minus I2 minus 3 I1 minus 2. As end is minus, so minus 2 equals to 0. If you evaluate this by taking right hand side to left hand side and all, you get 2 equals to minus 8 I1 plus 4 I2 plus I3. Then apply KVL to mesh 2. How to write for mesh 2? Again, as it is starting from here, take plus minus I2 plus minus 4 into I2 minus I1. I'll clear once here and then I'll show you once again clearly. See here, first it is minus plus, you take, as the current is flowing from this side, you take here plus, then here minus, take here plus and here minus. So plus here, plus here plus and here minus. If you see here, minus I2 minus 4 I2 minus I1, then if you see, as there is no I3 value here, so you take 0 I3. Why? Because we need to calculate, we need to put some value. If you take 0, there will be no difference. Then apply KVL to mesh 3. Mesh 3, how you will take the equations? As the current is starting from this side, so take plus here, minus here, then plus here, minus here. If you see, minus 4 I3 minus 1 into I3 minus I1. Why? Because we are considering third mesh. First to consider the third mesh current I3 minus I1. If you equate it and if you see, and you will get 4 I3 plus 1 into I3 minus I1, you will get minus I1, then 0 I2. There is no I2 component, so 0 I2 plus 5 I3. After getting the three equations, in mesh currents we need to find the different mesh currents equations. 3 meshes, how many meshes may be, you need to find that. After finding that, what we will do, we will solve 1, 2, 3 by using either Cramer's rule or the calci. You will get I1, I2, I3. We want all the mesh currents, we got I1, I2, I3. Here, after that we wanted the value of I. How to get the value of I? If you see, the value of I is between I2 and I3. So the current is going like this. This current is also going like this only. So I will be what? I2 minus I3. I3 is moving in opposite way to I2. So I2 minus I3. So I2 minus I3, that is minus 347.8 milli minus of minus 86.96. If you do, you get the I value. Simple. First we need to find I2, I3, I1, I2, I3. Then where you want I1, you want. As I1, if you see, it is, the I2 is in the same direction, I3 is in opposite direction. So you will take I2 minus I3. As a current flowing through this you want. Two currents are flowing. So I2 minus I3. Okay. So I have solved some questions. I hope you understood the questions. Please practice them so that while I'm explaining, please do that same thing in the paper so that you'll understand how the things are going on and how the equations are written. Then only you'll understand. Then these are the practice questions I'm giving for you. These type of questions I already did. If you see here mesh currents, if you apply for KVL to I1 and KVL to I2, you will get easily I1 and I2. See I1 and I2. Answers also have given. Then I1, I2, they want I1 and I2 currents. So to find what you'll do, you consider one more current here in the third mesh, that is I3. You find all the three meshes ka equations. After finding the equations, use calci for finding I1 and I2. You get I1 and I2. The same way there are other two questions also. Please solve them, and power dissipated also can be solved using 4 ohms. Don't get confused that how to do power dissipation. If you get I1 value, no, you can do I square R. Then you can get the power at this 4 ohms resistor. So easy. You need to think in different ways or different questions you need to practice. Then it will be easy for you to attempt the exam. Why? Because they will not give the same questions. So I am stopping the video here. We have already done with the introduction, circuit component definition, source of electrical energy, source of transformation, general network transformation, and today in this video we have completed mesh analysis. Now later in the next video I will do node analysis. Why? Because doing the same video it will be tough for you also. So mesh analysis I have done some problems. So now in later I will do the node analysis in the next video. I am stopping the video here. Thank you. From Sri Sai Tech Edu YouTube channel, read, lead, success. Keep reading.